Alright, problem number 6. We're to use partial fractions to write this fraction as the sum of three fractions. Managed to get the word fraction into that sentence 3 times. So remember, the first step to starting a partial fraction problem is to go ahead and actually factor the denominator. So to factor this denominator, we're going to factor out that x squared, and we should get this. And so now that we've factored it and we've gotten x squared times the quantity x plus 2, now we're going to actually split it up into our different fractions. And now this is where it gets kind of weird, since we have that x squared term, a nonlinear term, for one of our factors. We're going to need to split it up into actually 3 different fractions. So I'm going to go plus plus, and I'm going to split it up into x squared, and x plus 2. And again, this was explained in class, but that x is coming from that x squared term. So anytime you're doing a partial fraction and say for example, the denominator was x cubed times x plus 1 squared. Well, you're going to split that up into x cubed, x squared, x plus 1 squared, and x plus 1. So hopefully you can kind of see what I'm getting at with why we split it up like that there. Okay. Remember, we don't know what these coefficients need to be. That's what we need to find out. So let's just try A, B, and C. Give them some unknown variables that we want to find, unknown constants. Okay. So remember, just like the simpler partial fraction problems we've done up to this point in this study guide, it works the same way. Once we have this, remember that we are dealing with an equation. So anything we do on the left side of the equal sign, as long as we do the same thing on the right, we are totally fine. So what we're going to do is we're going to multiply everything by that denominator, x squared times x plus 2. So if we do that, if we are focusing on this as our main 2 equations, on the left side of the equal sign, we will be left with just our numerator. So I'll rewrite that. And on the right of the equal sign, we're going to literally multiply by that quantity, x squared times x plus 2. We're going to multiply that into everything that we have written already on the right. So if we do that, then think we're going to have to distribute each of these terms to each of these fractions. So if we do that, now I'm going to rewrite it with that. Notice if we look at our fraction with A, we're going to get x squared over x, so one of those x's are going to cancel out, and we'll be left with A times x plus 2, because that x right there eliminated one of those powers of x's. And then we'll get plus b times, notice now x squared is going to cancel out, and we will be left with x plus 2. And then finally plus c, and now notice x plus 2 is going to eliminate with x plus 2, and so we'll be left with c times x squared. So again, at this point, you could totally solve this with a system of equations. Just distribute in the a, b, and c, and then combine like terms and go from there, and then take the coefficients and get 3 different equations from that. But we can also use our cover-up method like we've been doing. So let's do that. Let's be smart about what x value we choose to substitute into this, because again, this should be true for all x values. So notice the 2 factors we have, x and x plus 2. So we are going to choose 0 and negative 2. So let's just choose 0 first, just for the heck of it. Substitute 0 in, every single place you see x in this entire equation. So negative 2 times 0 squared minus 4 times 0 plus 4 equals a times 0 plus 2 plus b times 0 plus 2 plus c times 0 squared. So notice that anywhere we have a 0 in this equation, a factor of 0 somewhere, that term's going to eliminate. So that 4 is going to go away. Let's see, that negative 2 is going to go away. We have a 0 there, so that whole term is going to go away. 0 plus 2 is 2, so b's good. And here we have 0 squared times c, so that's going to go away. So if we rewrite this, all we have on the left is 4, and all we have on the right is 2b. So 2b or not 2b, b is 2. Haha. I'm sorry, I know that was really bad. But now let's do the same thing, except instead of substituting in 0, let's substitute in negative 2. So if we do that on the left, we're going to get negative 2 times 2 squared minus 4 times 2 plus 4 equals a times 2 plus 2 parentheses plus b times 2 plus 2. And I'm realizing now that I messed this up, and I meant to do negative 2 for all of that. Because notice we have x plus 2 as a factor, so if we substitute negative 2 in, it's going to go to 0. My bad, so I got to go through and make all of these negatives. So I'll pause and do that. Okay, so that's all fixed now. Sorry about that. And let's go through and simplify this whole blue equation now. So starting over here from the left, we'll work our way to the right. Negative 2 squared is 4. Negative 2 times 4 is negative 8. Next term, negative 4 times negative 2 is positive 8. Man, I'm just going to eliminate those right now. And then, so all we have is 4 on the left. Again, that's kind of cool. Okay, and then let's start to simplify the right side of the equation. Notice in here we have negative 2 plus 2 is 0, so that whole thing is going to go away. Second term, we have negative 2 plus 2 goes to 0, so b is gone as well, and we're just left with negative 2 squared is 4, so we have 4c, so c is 1. Okay, now here's the problem. We cannot substitute a value in that will eliminate b and c to give us a, because if you look at a has the same factors as b and c combined, so we can't eliminate it that way. But we can choose another value of x to substitute in and simplify it and substitute our values for a and b into this equation and then solve for c. I'm sorry, for a. Sorry, however I said that, makes sense of it. So we're going to do that, but let's make it easy on ourselves. Let's choose an easy x value, so let's just do x equals 1. So if we substitute x equals 1 into this equation, and the values for b and the values for c into this equation, we get what we have here in pink, and we can simplify this. So 1 squared is 1, so we have negative 2 minus 4 plus 4, 4 and 4 canceling each other out. So we have negative 2 equals a times, notice inside the deepest parentheses we have 1 plus 2 is 3, 3 times 1 is 3, 3 times a, so we have 3a, plus we substitute 2 in for b, inside those parentheses with 1 substituted in for x, we get 1 plus 2 is 3, times 2 is 6, plus c is 1, so we substituted that in, and x is 1, so we substituted that in. 1 squared is 1, times 1 is 1, 6 and 1 is 7, so let's subtract 7 from both sides to get negative 9 equals 3a, and then finally divide by 3 on both sides to get a equals negative 3. So we have the three values a, b, and c that we were looking for, and now we can rewrite this partial fraction with its actual coefficients. So if we go back to the, oh wait, sorry, here, boom. So if we go back to the partial fraction we had written before, we can put our coefficients in there and get negative 3 over x plus 2 over x squared plus 1 over x plus 2. And what we're saying is that this equation is mathematically equivalent to the equation that we started with, negative 2x squared minus 4x plus 4 over x cubed plus 2x squared. Now, you would be done at this point. But honestly, do those two equal each other? Well, in order to figure that out, you should get a common denominator with your partial fractions and actually try to put it back together and see if it works. You don't have to watch this part, but I'm totally going to do that right now. I know some of you wanted to see how that works. I challenged you to do it. Hopefully you did. Maybe try to do it by yourself right now and then see if we did the same thing afterwards. Now, before we do this and get a common denominator and multiply back, think about how you would do it with this series of fractions right here, 7/4 plus 8/3 plus 2/5. Well, if you wanted to do that, you would need to get a common denominator between these three fractions. And it would go something like this. You would have to multiply by a different value on each fraction, but at each time, all you can do is multiply by 1 because you're not allowed to change the value of it. So, if we're clever, we can multiply by what I call fancy 1. So, with this first fraction, 7/4, if I multiply by the product of my other two denominators, 3 times 5, and I make that my numerator as well, well, 3 times 5 is 15. 15 over 15 is 1, so I haven't changed the value of this. And in my second fraction, I'm going to multiply by the product of the other two denominators. So I'm going to get 4 times 5 and 4 times 5. And again, that is the fraction equivalent to 1, so we're fine. And then finally, I'm going to get 4 times 3 over 4 times 3. And then I can start doing some math. I'm going to get a common denominator of 3 times 4 times 5. 3 times 4 is 12. 12 times 5 is 60. So I'm going to get 60 for all three of my denominators. 7 times 3 times 5. Well, multiply all those together. You're going to get 105 plus 160 plus 24 all over 60. And then you would add those numbers up and simplify your fraction, and you'd be done. Whoa, not dumb. Sorry, I don't know why I said that. But anyways, the process is exactly the same thing here. For each of these fractions, we would like to multiply each of those fractions by the product of the other two denominators. So if we do that, we're going to get negative 3 divided by x. We're going to multiply that by the product of the other two denominators. So we're going to multiply that by x squared. I'm going to go ahead and actually just distribute it just for fun. I'm going to say x cubed plus 2x squared over x cubed plus 2x squared. And again, that's the product of the other two denominators. And then I'll do the same thing for my middle fraction, except this time it's going to be x squared plus 2x over x squared plus 2x. Again, that's the product then of those two denominators. And then finally, my last one, I'm going to get the product of x and x squared is x cubed over x cubed. That's not a very good cubed, but use your imagination. Boom, that looks better. Okay, so now let's simplify some things out and let's see what cancels. And now I'm actually kind of wishing I hadn't multiplied those things in. So I'm going to rewrite that real quick. And I actually lied. I'm not going to bother to go back and change all that. This will work just fine, but let's see. We got a common denominator in each of these. That is x to the fourth plus 2x cubed. And now let's just go up and add all our numerators together. So I'm going to distribute the negative 3 into that first x cubed plus 2x squared term right there. So I'm going to get negative 3 x cubed plus, minus 6x squared. Then my next fraction, I'm going to have plus 2x squared plus 4x. And then my last one, plus x cubed. And if I actually factor 1x out of each term, 1x out of that denominator, each term of that denominator, to make x times x cubed plus 2x squared, well, notice that in the numerator, I have a power of x in every single term. So I can eliminate that x, and that 3 will become a 2. That x is gone. That 2 will become just an x. That 2 will become just an x. And that 3 will become a power of 2. And now we can combine like terms and see, hopefully we're back where we started. So we have negative 3x squared, and we have a positive 1x squared right there. So we're going to have negative 2x squared. Then notice we have a negative 6x and a positive 2x. So negative 6, positive 2. We have negative 4x plus, we just have that one lonely constant term, 4, over our denominator, x cubed plus 2x squared. And if you will remember that negative 2x squared minus 4x plus 4 over x cubed plus 2x squared is what we were saying we wanted to find when we found a common denominator and wrote those partial fractions as one fraction. And also remember that negative 2x squared minus 4x plus 4 over x cubed plus 2x squared is what we started with way back in the beginning. So there is a total, fully complete partial fraction problem for you, and holy moly, that is a long explanation. I wonder if any of you will actually get to the point where you're hearing the words that I'm saying right now. If you're hearing the words that I'm saying right now, next time you see me, come into class and just be like, hey, Mr. Reed, I'm a go-getter, I'm a stick-with-it kind of guy. And I'll look at you, and we'll make eye contact, and it will be known that we understand, that you're awesome, and you watched through this whole ridiculously long video.